Okay, let's get started.
Oh, okay. So hi everyone. My name is William Liu. My teammates are Xiao and Kunpeng Jiang. Today we are going to discuss NBA player salaries prediction. So first of all, what's the motivation behind this problem? Um, so predicting salaries of players for the next season will be very helpful for a team manager to build a team. So let's say if a team is pretty small or this team has a cost gap for the next year, uh, by solving this problem can help us to find out which player to choose, and that will help us to allocate all the team's resource more efficiently. So that's one of the motivations behind this project. And as we know that usually before we have machine learning models and data analytics methods, when a team manager trying to build a team, the only way to build a team is to try to see the stats of this player and um, how this player is gonna benefit the team in terms of the style of their play. But by aggregating or integrating this additional salary factors, we can actually help the team manager to build a team not only in terms of player performance, but also in terms of money allocation. So that's another motivations behind this project. And originally, we want to predict the win-loss for one team based on the player performances. But later, we find out that it may not be very helpful or meaningful. So we decided to only predict the future salaries based on previous performances of players. And so our data sets, so we collected data from season 2020 to season 2023. And there are 10 teams in our data sets. They are Hawks, Timberwolves, Raptors, Pelicans, Thunders, it should be Bulls, Lakers, Heat, Warriors, and Nets. So those are the 10 teams we choose to include it in our datasets. We have a bunch of metrics such as points per game, rebounds, assists, steals, blocks, shooting percentages, turnovers, and efficiency ratings in these datasets. And we also have some other features such as the awards. So we have All-Star selection column. We have the MVP awards data. We also have like all NBA team appearances data in our training. And so we try to use those features to serve our model. But before serving our model or perform any data analysis, we want to make sure that our data is clean. So we perform data processing and data cleaning. So first of all, there are some columns that may be duplicated or repetitive. For example, we have three-pointer attempts column. We have number of three-pointer made column, but we also have three-pointer percentage column. So in this case, you see three-pointer percentage column is actually the same as three-pointer attempts, three-pointer made divided by three-pointer attempts. So we don't need to include the three-pointer percentage column here. Next, because we try to predict the salaries of every NBA players, our prediction value will just be the next season salary. So next season salary will be our Y values. And when we train our model, we need to have the test data for, I mean the the Y column for training data. So any rows with null or NaN, we're gonna remove that. And we're also going to create dummy columns for words. So this will actually be more clear if we just dive into the data sets now. So as you can see, there are two graphs. The one on the top is the one we didn't actually perform any data cleaning yet. So there are some columns like season, ages, team, and LGX. So those columns are like seasons or team and LGX. Those columns are not meaningful for predicting NBA players' salaries because they don't contribute anything to the players' salaries. But statistics such as the ages, the position, the player stats, those are the factors that will influence the player salaries. We also have awards column here, as you can see on the right. It's like ROY2, so that means Rookie of the Year 2. And the 2 here means the second place of these awards. So we're gonna take this column of data into dummy variables, as I will show in the code later. So and in the first graph, we also have salary on the right and the next salary on the right, the rightmost here. So this next salary value is obtained from the second row. So for this player, let's see the salary is like for 2012 to 2013 is 5144 something. And for the 2013 to 2014 season, the salary is 5375 something. So we're gonna take this salary from 2013 to 2014 to the first row. So we try to create a new column here to work as a next salary column. And the graph at below is the results of our data cleaning. But let's move on to the code here. So first of all, we have 10 teams because each of our team members trying to collect data. So there's some data preprocessing or allocation needed to be performed here. So for each team, for example, in Raptors and Pelicans, because we kind of combine the data differently, so we have to clean each data set separately first here. But the idea here is that we have these columns and we're gonna drop some useless columns like player, LGY, and we're gonna rename some columns to be next. We're gonna rename the next salary column to next salary to make sure that it's consistent across all data sets. Yeah, so all the data sets for here, like for the teams, are the same. And the reason we do that is that we want to concat them vertically into one data frame at the end. So this, as you can see, is how we're gonna combine all the data at once using the pandas concat function. And then we're gonna drop the null values here. So we're gonna drop the rows with null values in the next salary. That's why we set the subset equals to next salary. We are also gonna we are also gonna drop the rows with null values in salary because that's gonna be our feature too. And the season column, as I said before, it's not useful here because the the time of the year doesn't mean anything to a player's salary. And here is just more data preprocessing. In the salary column, some of the values are having a comma and those non-numbers, non-digits characters. So we're gonna remove that. So yeah, same here. Like you see, there's like $ here and TW. It doesn't mean anything here. So we're gonna remove that into real numbers. And finally, we're gonna do the label encoding here. So we have position like guard, point forward, and etc. And a machine learning model will not understand those. So we have to convert those categories into numbers. So that's what I did here. And finally, we have awards columns. Like I said before, it was like Rookie of the Year 4 and etc. But we wanna make sure all the awards are columns. So we wanna transform those columns into dummy columns. And here's just trying to see there are these many different awards. But some of those are repetitive at first. So Rookie of the Year could appear somewhere here again. But we only want Rookie of the Year to be one column only. So, but at the same time, we also want to make sure that the 4 is recorded because that 4 means something. That 4 means that this player is ranked number 4 in this awards category. So a player that is ranked at the first place for this awards definitely is doing something better than the number 4 player here. So that's why I created this function. We split the and also I created like a dictionary to store the awards. Make sure that the key values are the awards and the values are just the rank or the rank of this person's in this awards category or this person. Yeah, the value is the rank. Yeah, and then just trying to concat these awards dummy columns together with the original data frame here. So right now we not only have columns such as a player sets, but we also have if this player has these awards or not, and if this player has these awards, what's the rank of these players in these awards. And that's it about the data processing part, but now let's move on to the data analytical parts and pass it to Xiao.
I will introduce. Oh, wait a second. Let me share the screen. Okay. Now let me introduce the data analytics. At first, we will calculate the summary statistics for all the variables, such as age, points per game, assistant per game. And then we will find the correlation metrics for all the variables to find out their relationship. Use these correlation metrics can help us find the most related variable, so that could be used for the future engineering. And the next step is to prepare for the modeling step. So we need to split the data into training and testing data frames. We'll do some statistical analysis on those variables to filter out those extreme values. And then the visualization part will show us for each variable how they are distributed and their trend. Last but not the least, we will calculate a advanced matrix called player efficiency rating to measure how a player is doing bad or good. Now let's move to the coding part. So at first we will read the data frame from the CSV file. And as you can see, we have so many variables, but they are all in abbreviations, and I have listed their meanings so that we can find out their relationships more clearly. At first, we'll fill the missing values by mean, and then we find their statistics. For example, their mean, their max, their 75 percentile, and then we'll split the data into train and test data frames. And we will find out the 2.5 percentile and 97.5 percentiles, and then we will filter out extreme values above and below this range. I created this function to draw the pictures of histoplot and box plot for each variable. I split them into training and testing data to see if the two data sets are different or not. And as you can see, the latter part is showing the showing the histogram for each variable, and then the right part is showing the box plot for each variable, and all the extreme values will be the circles like this. So this is the data visualization. Let's go through the correlation matrix. I created a heat map to show how each variable is related. And we will, because we want to predict the next salary, so we will find out the salaries that has the most correlation value to the next salary. And we set a threshold to be 0.15, and those variables are considered as potential features that could have an impact on our y hat. I also printed out the sorted values of those variables, which will be ranked from high to low, so that we can see which one is most relevant to the next salary. That is data analytics. That is data analytics and data visualization part. I will hand this to Kunpeng, which will introduce the modeling part.
All right, so let me share. All right. Okay, so here's the model part. So here I just imported the model, which is the same as the data analytics part. And I here's some pre-processing before we feed the data into the model. So I have to drop rows like where the next salary is missing, because maybe some players have no next season, or maybe they have next salary uploaded to the website. And there's some missing value in other columns. I filled with medium values. All right, and I separating the features and the target variable. So we have X and Y. So we don't have to do that again. We just need to fit into the model. Here we split the data set into training and testing set with a ratio of, I think it's 80% and 80% and 20%. Okay. And here I standardizing the features because for example, for linear regression, you have to like standardizing the data because that will be helpful for the model to read the data. All right, here's some final result for the data shape. Cause we don't have too much data here, because it's pretty hard to get the data from the website. But so if in the future we could use some like other data source or maybe some other method to extract the data from the website, that's gonna be a better way to do that. So here we have about like 100 data for training. All right, here's the first model we used, which is a linear regression. So linear regression is a linear relationship between the input feature and the target salary. Pretty straightforward and interpretable. So that's why we chose it as the first choice for the initial analysis. So for the linear regression model, we got a R-squared score of like 0.956, 0.9567, and which means that it explains a significant portion of the variance in the salaries. It's pretty simple, but it considers some predictive power with like MAE is around like $30.7 million and the RMS is about like $61.3 million. It's pretty high because that's like what like what I said, we only have $1,600. I mean 1,600 data. So in the future, if we could have more data and more maybe features, this result is gonna be more accurate. Okay. And here we have the second model, which is the decision tree. So the decision tree split the data into subset based on the feature values, like creating a tree-like model of decisions. This model is pretty intuitive and can capture nonlinear relationships, but it's easy to overfitting. So in our case, the decision tree outperformed the linear regression with a R-squared score of like 0.971, and it was more accurate in its prediction, like having an MAE of approximately like $14.6 million, and RMSE is around like $50 million, right? And its ability to deal with complex pattern makes it a strong candidate for our like prediction tasks. Yeah, just remark this. And here's the third model, random forest. And it's a simple approach that combines multiple decision trees to improve the prediction accuracy and control fitting. While it's less interpretable than a single decision tree, but it's more robust and able to handle like complex data set efficiently. And it has a R-squared score of like 0.941, and the MAE is roughly like 16.48, and our MSE is about like 70.1.9 million dollars. I mean, it didn't outperform the decision trees in this case, but its generalization capabilities make it a valuable tool for some like predictive tasks. And we also tried some other models, but they were not efficient enough. So, like in this case, like the Sentry model showed the best performance in the analysis part, like for predicting the NBA players' next season salary. Even though the error is pretty high, but like what I said, in the future, if we can get more data, that's gonna be better. Okay. So the choice of a model can depend on some specific requirements of the task, like maybe like complexity of the data, interpretability, something like that. But in this case, like decision tree could be the best choice, right? So that's all for the model part and all for the project.
Thank you for listening. Let me end recording.